Okay, so let's take a look. First question is a standard kind of bubble sort. Cannot. So it's a standard bubble sort. So I'm going to go through with you. First, you open the file, read the lines, and then put that into a list. Put that into a list. So I'm going to print the list. Okay, I'm going to print the list. Let's run. Print the list. So we have the list. We are able to read that. Okay. And then the next part is the bubble sort itself. Right. Now, if let's say the length is less than 2. Okay. Now, what do you mean by the length less than 2? That means there's only one element or no element. Okay. Then straight away just return the list. No need to do any bubble sort. Because less than 2, that means one element or 0 element, no need to sort on. Okay. Now, here comes the part. Now, the signature of a bubble sort, you can see the 2 for loop. 2 for loop. Okay. So, let's look at the inner for loop first. Inner for loop. This inner for loop. Okay. Is it too small? Let me increase it a little bit. Okay. The inner for loop here, it basically says that if the element is bigger than the next element, second element is bigger than the third element, for example, then you do the swap. You do the swap. I think by now the kind of swapping Python way of writing the swap is very easy, right? Correct not? So you do the swap. So the inner loop is our first iteration, right? And then you need to repeat this again and again and again. Okay, so that's the outer loop. Outer loop will do the iteration. Correct not? Now, then what happened is that here is the improvement part. If let's say you don't care, you just iterate the whole length of the list, it still work. That means without this minus j, you iterate the whole thing again, it will still work. Okay, so let me run this and do this, and then I print the list. Okay, can, and it's sort according to alphabetical order already. Okay. Now, so down here, when we put the minus j, what do you mean by that? That means because the last element is already taken care of by the previous loop, previous iteration. So the last element you don't really need to consider. You can consider one element less. First iteration, you go through 4 elements. Second iteration, you only go through 3 elements will do. Third iteration, you only go through 2 elements. You understand? So as you iterate, you get lesser and lesser element to iterate, that's all. Okay, so it becomes faster. But if somehow you forget about this and then you just iterate the whole thing, you are still correct. You won't get penalized. Okay, it's just that yours is not the most efficient one, that's all. Okay? Okay, so this is a traditional bubble sort, which should not be a problem. Okay, then we look at the pseudocode that's given. Okay, pseudocode that's given. Now, take a look at this pseudocode. Okay, take a look at this pseudocode. How many iterations do you see? How many for loop do you see? One. There's only one for loop here. So something must be wrong, right? Because we expect bubble sort to be repetitive of the iteration, right? Correct? So this fella is a recursion. It calls itself back again. It's a for loop plus a recursion. It calls itself back. That's where it recurs. You understand? Not? Okay? So down here, now when you do a bubble sort of the array n is actually the full length of the array. Now when you recursively call it, it gets shortened and shortened and shortened. Eventually your n value, the length, gets so small until it. Now this return alone means that it will terminate the whole program because you return nothing. Once you return, it terminates. So this if for A, what is missing here is actually a base case. When you hit the base case, and what is the base case? When you have less than 2 elements. That's a base case. C, the line C is a recursive call on itself of a shorter length. You understand? A smaller n. So it's a sub case, a sub task of it. So you get lesser and lesser. So that's recursive already. The rest down here, now this tree line is a traditional way of swapping. Python, we have one line, you can do the swap, right? But in traditional programming, where you write pseudocode, they write it in three lines. So when do you do swapping? When the second element bigger than the third element. When I element bigger than the I plus 1 element. You understand? You do the swapping. Okay, so I hope this makes sense to you. And then let me pull out this so that you can do the comparison. Okay, here you go. Hopefully with the explanation, it makes sense to you now. A, which is the base case, when n is less than 2. Okay? B, when list at I index is bigger than list at I plus 1 index. The second element bigger than the third element, for example. Okay, that's where you do the swap. The last one, C, is a recursive call. It calls itself again using the same list, but this time around n minus 1, one element less. Right? So if you start off with 5 element n, the next time you call it again become 4 element, and the next time you call it again become 3 element, call it again 2 element, call it again become 1 element, it terminates. It returns the list that is mutated, and it will be a sorted list. Got the idea? Got the idea? So this is not a traditional way of writing. It has a for loop, it has a recursion. Okay? So can you please digest this? Then we can go ahead and do the coding. So our version 1, if n less than 2, return. We don't need to talk about n if. Then we have the for loop. For I in range, okay, we don't need to follow 0 all the way to n minus 1. Now, in pseudocode, it is inclusive up to n minus 1. It is inclusive up to n minus 1. So, we will go up to n. Okay? Later on, if I run into error, then I'll change it to n minus 1. Okay? For now, I just leave it as n. Because our Python coding, it doesn't include n. So, it's n minus 1 actually. Okay? Then we do the swap. The array, so this is the list I and the I plus 1 do a swap equal I plus 1 and I. Okay, so that's done. Okay, sorry, I've forgotten to check if, right? If the list is bigger than this, if it's bigger, then you do the swap. Sorry, I skipped one line just now. So if it's bigger, then you do the swap. Okay, I'm done. The for loop, done. Then I call recursive. And what do I call? I call the bubble sort with n minus 1. Okay. So that will do the trick. Okay. Converting the pseudocode over here. So let me run this test case. And then I print list 1. Okay. Let's forget about list 2 and put a pass here. And then okay. So I'm going to run this test case. Run. Error. Okay, there's an error. Index out of range. It's because of the range n and n minus 1. So let me put it as a n minus 1 and run it. Okay, it get through and it's sorted. Okay, let's move on. Now, then the next task, they want to include a counting mechanism. Count what? Count whether there is comparison. Now, comparison doesn't mean there's a swap. Now, down here, this is the line where you do the swap. Okay, so your counter should not be here. Your counter should not be here. You don't do a counter plus 1. You don't do a counter here because you're counting the swap. Understand that? You should do when there's a comparison. For every single step that you go to, it actually compare. Right? Down here, this line is comparison. Whether it's swap or don't swap, you already counted already. You understand that? You already compare. So you should put a counter here. Okay? Now, let me copy this set of code. This version 1, the version 2. Okay, version 2. Version 1 got no counter. Okay, let's talk about version 2. There's a counter. So I have a counter that I'm going to put here when I do a comparison. When I first come in, I must initialize a counter equal to 0. And then as I go through the iteration itself, I get my counter. Right? Then here, I must sort of take the counter plus whatever the next counter counts, right? Correct out? And this whole thing eventually will have to return the value. Okay? Return the counter, the value. Okay? So I'm going to run with the same list. And then this time around, when I print this, when I print the outputs from this bubble sort, that will give me the counter. When I print the output from the bubble sort, that will give me the counter. When I print the list, it will be a sorted list. Got it? Okay, let's run. Okay. Print, return, counter. Okay, let's see what's the error message. Unsupported. There's a none type. There's a none type here. Okay. So it's my base case. Base case, I return. So this one, I should return counter. Okay. I cannot return nothing. Got it? Okay. So I return the counter, and the counter is a 0 because when it comes to the base case, no comparison is done. It returns the counter, which is 0. I can say return 0 also. Okay, so I return 0. Okay, no comparison. So that's a base case. Let's run it. Okay, so they're all together 28 comparison. 28 comparison. Got it? Okay, so that is the version 2 where it does with a counter. Can? I think we are done for this question. Now, talking about the time complexity, that means if I have 5 elements, I need to compare 5 times, and I need to repeat this 5 times. So it's 5 times 5. So it's a 5 square. So if you have n element, it will be n times n. So it's an n square time complexity. Worst case scenario. Okay, cannot. So time complexity is a worst case scenario. So that is the O square. Okay, so we are done with question 2. Question 3. Right? If there is no swap observed, there's no need to iterate. So let's take a look at this algorithm. Right? We do not want to call it recursively if there is no swap. Right? Because once there's no swap, it stops already. That means that's the end of the bubble sort already. You don't want to call it again. So I must have a flag. I must have a flag to stop my recursion call. Okay, so I'm going to copy this set of code. I'm going to copy this set of code and paste it over here. Okay, copy. The counter is still there. Later I'm going to use the counter. Okay, so I need to have a flag. So I say swap. Okay, swap equal to false. Okay, then when there is a swap equal to true. Okay, if swap equal to false, return counter. Okay, return counter, else. Okay, if let's say there is no more swap, I just return the counter, and that's the end. But if let's say there is still swap, I need to call buffer sort recursively. Okay, I'm going to copy the same test case. Just now it's 28. So now copy this. Let me put the end here. Just now there are 28 comparison. Now let's run it. I need to print the output. $18. So there's 18 comparison, right? Because we terminate calling it recursively. Here, you only call it when the swap is true. When it's still true, you call it. Once it reach false, you don't call it anymore. You terminate the thing. Can? So that's all for the buffer sort.